I'm Alicia. I'm the Senior Data Scientist at Neo4j, and I'm the Technical Product Manager for the Graph Data Science team. We make graph algorithms that run on top of the Neo4j database. So the Graph Data Science library is a plugin that sits on top of your Neo4j database, and what it lets you do is it lets you flexibly reshape and subset your database to run kind of analytics and machine learning AI workflows. It includes both the technology and procedures to reshape your graph into an optimized data structure to do analytics, as well as a package of 48 algorithms across 3 tiers, so alpha, beta, and product supported, to basically summarize key aspects of the topology of your graph, like how important are different nodes, or what are the communities of nodes, or how many paths are available. So you can kind of take the information in your global graph and make it into something that's machine interpretable or even human interpretable. So we've seen really 3 big first use cases in our first batch of kind of early adopters. Far and away, the most popular is fraud detection. So looking for unusual patterns in transactions or the use of identifiers, or what does your behavior look like, and are there any nodes that are outliers? So this node is much more highly connected, or this node has a really short path to a known fraudster. Kind of ways of summarizing behaviors and finding anomalies. We also have some customers using the algorithms library for disambiguation. So basically saying, I have all of this data, which nodes are actually duplicates, or which groups of nodes actually all represent the same thing. So we have customers using algorithms like node similarity or weakly connected components to say, out of all of this data, I have hundreds of nodes, or I have billions of nodes. How many actual users have I seen touch my product? How many of these online profiles that I've built are actually the same? How many of my account holders or account creators are really the same user? And be able to then leverage that information to track a customer's journey across multiple platforms or many different data sets. And then the third use case is really around targeted marketing. So if I have a message that I want to communicate about a product, who do I target? And in the past, we've talked about marketing with Neo4j doing things like collaborative filtering. So, customers who bought this item also bought this item. But if we bring data science to the table, we can say something like, who's the most important customer that you know based on your social connections? And maybe they're way more influential, and so we should recommend what they bought to you instead of something else. Or what other customers look a lot like you based on their buying patterns, their transaction history, their customer journeys. And we'll make recommendations based on this similar topology instead of just kind of blindly querying. Yeah, I think the main power of graph data science in general is it's a way of taking relationships into account. So if you're like a regular data scientist in Python land, everything is rows and columns. There's no way of linking together data points naturally. You have every row is something you're trying to predict, and you have descriptors. And if you think about people, it could be age, gender, location. The graph lets you link your things together with relationships. So who knows who is connected to who's important, how does information disperse across the graph? And then you can start to look at these multi-hop patterns in kind of traversals or kind of, dispersals across a graph. And so we really say, like, when do you graph data science? It's when relationships matter. If there's no relationships amongst the things you're trying to predict, you probably don't need us, but odds are there are. And that's what the Graph Data Science Library is for. I think a really good place to start is framing your question. So not just, I have a graph, I'm done now. Really spend a lot of time thinking on, what do I want to answer? How do relationships matter? Is this a graphy question? And then figuring out what's the right match for your question amongst the algorithms that we offer. So do you have a question about how do I subset my graph? Well, then I'm maybe looking for community detection. Or if I want to say who's important, well, that's a centrality algorithm. And then once you kind of know what you're trying to answer, that reflects back on what data do you go after? How do you structure your graph? How do you get started, and how do you measure success? So will be available in Neo4j desktop. You can click, install under plugins, the Graph Data Science library. It's available on our download center or on our GitHub repo at Graph Data Science. And we actually have a browser guide, so you can type in Neo4j browser, play Graph Data Science, hyphenated, and you can get started that way. Or we have Graph Data Science up in the Neo4j sandboxes, so you can kind of have a curated experience and introduction to get you started quickly, both with running algorithms as well as using Bloom to visualize the results of the algorithms to kind of understand what all those numbers and patterns mean.